Yeah, today we're going to be talking about solid principles. Remember, I told you this month we'll be talking about object-oriented programming. Now, when I talk about OOP, I want you to think Java, think languages like C#, think Python even. Okay, now solid principles are a set of design principles that make it easier to build software that is, maintainable, software that is easy to read and understand, and software that is focused. So as a developer, as someone who codes, if you understand these solid principles, it will help you. Okay, let's dive right into it. The first one is the single responsibility principle. Now, the single responsibility principle is pretty much about each class having one job and one job only. So it says that each class must have only one reason to change. So one class, one responsibility. When you follow this principle in your code, you will find that your code is more focused, your classes are more focused, and are less likely to change due to unrelated requirements. The second one is something called the open-closed principle. One of my favorite, because I find myself using this a lot when I code, and it's about your code or your classes being open to extension but closed to modification. So what that means is that as new requirements come up in your project, you should be able to extend the behavior of your program without leaving the source code open or vulnerable to any changes. What that means is that if I want someone else to build on what I've built, they should be able to do it. They should be able to extend what that program does without essentially changing the source code. Okay, so when you do this, you will find that you have code and you have projects that are less likely to have bugs introduced to them as you develop and build on them more and more. And then there is the Liskov Substitution principle, right? And what this principle pretty much says is that objects of a superclass should be replaceable with objects of its subclass. So you should be able to switch out objects of a subclass and interchange it with its base class without affecting the behavior of the program. Yeah, so you're building something, you've defined a parent class, a superclass, and you've gone ahead to create child classes, subclasses under that. You should be able to take the objects of the subclass and put it into the parent class, and your code doesn't change. What does this do for you? It makes your code consistent. It makes it easy to track changes as you introduce more classes, right? You want your code to be predictable. You want your program to be predictable even as you introduce more classes further down the line. That's the Liskov principle. So then there is the interface segregation principle, which pretty much states that clients should not be forced to depend on interfaces that they don't use. I would think this one is common sense, but you'll be surprised sometimes what you can be tricked into doing when you're coding. So I think the key around this is think smaller, more specific interfaces. So when you're building a project, don't go for big monolithic interfaces. No, focus on building interfaces that are small and that are specific to client needs. So tailor the interfaces to the client needs. And what you'll find that this does is that it reduces the need for coupling between components, and it also ensures some form of consistency and prevents the impact of change. It minimizes the impact of change when you're building a project. So then there is the dependency inversion principle, and what it pretty much talks about is that high-level modules should not depend on low-level modules. Yeah, so when you are creating your program, when you're building a project, always remember that your high-level modules, your low-level modules should all depend on abstractions. So this particular principle encourages the use of abstractions. And even these abstractions shouldn't depend on details, but details should depend on abstractions. So when you talk about abstraction, you talk about abstract classes, you talk about interfaces, and these all encourage, decoupling modules, making them more interchangeable, making them more manageable. You'll find that as you use these 5 design principles in your object-oriented programming, you begin to write code that is cleaner, you begin to write code that's easier to maintain, you begin to write code that is scalable, because when you want to extend, when you're adding more modules, you'll find that staying within the confines of this principle helps you do some coding magic. So if you've enjoyed today's episode, give me a follow, give this video a thumbs up, and I will see you in the next video. Have a good day.